All right, so here we are back with our last transformations lesson. And so today we're going to look at what happens when we put a number in front of the function. So our functions, again, if I start with y equals x, then all this is saying is put a 2 in front. So this is 1L, y equals 2x. Okay, if I start with y equals x squared, that was our second function. If I put a 2 in front, it's y equals 2x squared. And our next one was the absolute value. So this is y equals 2 times the absolute value of x. And y equals 2 times the square root of x. Okay, so we're going to take a look at these guys and take these guys off from the other day. All right, so y equals x and y equals 2x. All right, now still starts at 0, 0. And again, the reason for that is because I didn't change the y-intercept, but I did change the slope. The number in front of x is your slope. So you'll notice instead of going up 1 over 1, up 1 over 1, this guy goes up 2 over 1, up 2 over 1. So a 2 in front is changing the slope of the straight line to y equals um, 2x, which is a slope of 2. So here's my parent function. That's y equals x. And so my new function is simply going to be up 2 over 1, up 2 over 1, or you could also go down 2 over 1. And we'll see if we can get a straight line down here. There we go. All right. Our next one is our parabola. So I'm going to go ahead and graph the parent. 0, 0, up 1 over 1, up 3 over 1, up 1 over 1 to the left, up 3 over 1 to the left, and down and around, and back up the other side there. Okay, so now that we've got our parabola graphed here, our parent function, let's go ahead and take a look at the graph of y equals 2x squared. So here's y equals x squared. There's our parent function, and y equals 2x squared. Okay, so it has the same vertex, but it looks a bit skinnier than the green parent function parabola here. Okay, now I want you to go back. I'm going to take this guy off for a minute. I just want you to look at the pattern of points here. Okay, so we've got 0, 0, our vertex, and then remember our pattern was up 1 over 1, up 3 over 1. Okay, so watch what happens when we put 2x squared in there. Look at the first set. I still start at 0, 0, but the first point doesn't go up 1 over 1 like it did on the green one. It goes up 2 over 1, and I land on the blue parabola. And I don't go up 3. I mean, look what happens if I go up 3. 1, 2, 3. I don't make it all the way over 1. So watch how far I'm going to go up from this point. Remember, normally on the parent parabola, it was up 3 over 1. This is up 1, 2, 3, 4, 5, 6 over 1 to land at the point at 2, 8. Okay? So what's happening here, well, let's go back and graph this. So we have our parent parabola, and then we have our new one that starts at 0, 0, but instead it goes up 2 over 1. Up 2 over 1 to the left, but then it went up 6, 1, 2, 3, and I'm actually going to erase this guy and move him up a little bit here. So we'll go y equals 2x squared, and when we're going to count 1, 2, 3, so I'm going to guess 4, 5, 6 over 1, and I would do the exact same thing on the other side as well. So this parabola is a lot steeper as it goes up, and what's happening is the distance between the points is doubling. So again, on your parent parabola, it was up 1 over 1. Now it's up 2 over 1. On the parent parabola, the next one was up 3 over 1. So now we're doubling that, up 6 over 1. Okay, so that's what we're looking at here. Let's take a look at absolute value of x. So we'll go back over to here, take these guys off, put our absolute value function on there. I don't know, maybe you have a guess as to what this is going to look like already. So if I do this, I get the green absolute value. Notice the slope on the right side. On the parent absolute value, the slope is up 1 over 1, up 1 over 1, up 1 over 1. On the green one, it's up 2 over 1, up 2 over 1, up 2 over 1. Because remember, absolute value is just two straight lines. That's all it is. It's two intersecting lines that stop at that vertex down at the bottom there. So same vertex, just a different slope here. So I'm going to go back over. We'll go ahead and graph our absolute value. Our parent function was 1 to 1 on the right, -1 on the left, and our new one is 2 to 1, up 2 over 1, up 2 over 1. And then on the left, it's actually a slope of -2. So coming down, ooh, boy, that was terrible, wasn't it? That looks pretty bad, huh? So you got the idea, though. Should be a straight line if I can. All right. Now, what's it going to do to our square root function then? So let's go back and take a look at that guy. So we've got the square root of x. Take that guy off. There's our parent function. And 2 times the square root of x. Again, notice the points. It still starts at 0, 0. Normally, our pattern was up 1 over 1, up 1 over 3 to get to here. But now we're going up 2 over 1 and up 2 over 1. We're doubling the vertical distance, okay? So this number that's in front is not doubling all the distances, up and over. It's only doubling the vertical distance up. So normally, again, this first parabola, the parent was up 1 over 1, up 1 over 3. The new one is up 2 over 1, up 2 over 3, up 2 over 5, up 2. Okay? So we've got the parent parabola, or parabola, the parent square root right here. And we have our new one, which goes up 2 over 1, up 2 over 3, and it stretches it vertically. Okay? So what I want you to do is turn off the video, graph the next set, see if you can figure out what's going on when you put a 1/2 in front of the x, and we'll come back and take a look. Okay, so I went ahead and graphed the first couple here, and so now what we're looking at is y equals 1/2 x. Again, this is a linear equation from Algebra 1. Slope 1/2, y-intercept 0. So I start at 0, I go up 1 over 2. If you compare that to the parent function went up 1 over 1, just like this. So the parent function had a steeper slope. This one just has a different slope. Not as easy to see what's going on there necessarily. If you go to the parabola, I didn't graph the entire parent function parabola, I just graphed the blue dots. But now I want you to look at the pattern of points again. Remember, on a parent function parabola, it was up 1 over 1, up 3 over 1. Now I'm going up 1/2 over 1. Why am I only going up 1/2? Because this half in front here tells me to go up 1/2. And then I'm not going to go up 3 over 1. I'm going to go up 3/2 and over 1. Okay? So basically what this is doing is it's cutting the vertical distance between the points in half. Okay? If that makes sense. It's cutting the vertical distance between the points in half. Take a look at the absolute value graph. This is y equals 1/2 times the absolute value of x. Now, absolute value is kind of like lines. the parent function, up 1 over 1, up 1 over 1, up 1 over 1. Now that I have a half in the front, I can go up 1 over 2, up 1 over 2, up 1 over 2, and I can keep going. My square root function, y equals 1/2 times the square root of x. There's my parent square root function right there. You can see in blue. All I want to do is cut the distance of the vertical move in half. So you can see normally I would go up 1 over 1. I'm going to go up 1/2 over 1, and I'm going to put a point there. And then after that, I would usually go up 1 over 3. I'm going to go up 1/2 over 3, and I'm going to put a point right there. Now look at the coordinates of these 2 points at the end here. The coordinate on this far point up above in blue is 4, 2. The point below it is 4, 1. It's half the height of the blue point. Why is it half the height? Because there's a 1/2 in front of my square root. Okay, so this graph here, the graph of y equals a times f of x, is transformed by stretching. Okay, that's what happened above, stretching the graph by a multiple of a units. Okay, so a is the number in front, a units, when a is greater than 1. That's the example we saw up above. It was a 2x. Okay, so everything doubled the distance. If it would have been 3x, it would have tripled the distance. Or by compressing when, and I'm going to leave a little bit of a space here, a is less than 1 but greater than 0. So this was 1/2. I could have used 1/3 or 1/4 or 1/5 or 1/6. Okay, this type of transformation is a vertical stretch or compress. All right, so it's like keeping the vertex at 0 and pulling the rest of the graph up to stretch it out, or pushing it down to shrink it down. Okay? All right. What else do we have here? Okay, so this kind of the wrap up of all that we've talked about here, and this is what we're going to be doing, is putting all of these transformations together. So we're going to start off by looking at the a value here. Okay, so each of these arrows goes to a different section. The a value here. Okay, the a value did a couple of things. Reflects over x-axis if a is negative. Okay, it's a vertical stretch like we just saw, vertical stretch. If a is greater than 1, and it's a vertical compress or shrink, whatever you want to call it. Vertical compress when a is greater than 0. Oops. Yep. A is greater than 0, but less than 1. Okay, so a can do a few things here. All right. Let's see our next one. the plus minus h in the middle there, the plus minus h, that was our horizontal shift. Okay, and we said it moves h units right when h is negative and left when h is positive. Okay, and then we had a plus minus k out at the end. This was our vertical shift. Okay, vertical shift. And so we had k units up when k is positive and down when k is negative. All right, and then we had one other one, which we're not going to look a ton at, but that was what happens when we have a negative x in front here. And that was a reflect over the y-axis. All right. Now, the other thing you got to keep in mind here is these transformations, these are easiest to do when you work from left to right. And that's exactly how I'm going to work as I go to graph down below here. Okay, so we're going to take a look at putting multiple transformations together. I'm going to do some of these with you, and then I'm going to have you try some on your own. Okay. So I'm going to pick some of the trickier ones here maybe and talk about those. So the first thing I'm going to do here is I'm going to start with part A here. So part A has two things going on. We have a vertical stretch and we have a +1 on the inside, which moves us 1 unit to the left, or yes, 1 unit to the left. 1 left. All right, so this is a parabola. So what I'm going to do is I'm going to graph the parent function parabola. Okay, and I'm not going to draw the whole thing. I'm just going to draw the dots here. I'm going to put the dots on for the parent function parabola. And I'm going to work this equation left to right. So the first thing I need to do is I need to stretch all of these dots by a factor of 2. Okay, so that's going to be my next thing. I'm going to stretch them all by 2. So the vertex doesn't move, it stays at 0, 0. But instead of going up 1 over 1, I go up 2 over 1, both ways. And then I go up 6 over 1. 1, 2, 3, 4, 5, 6. We're going to call it right here. There we go, on both sides. And I know this one's going to be flying off the page here, but that's okay. And then I want to move all those green points 1 to the left. So this is going to be my final. 1 to the left of the vertex, right there. Each green point moves 1 to the left. So all I got to do is take all those green points, whoops, and move them all 1 to the left. And that's it. It's that easy. So then I draw my final picture. You just have to be careful with your other dots so you don't get them mixed up. Okay? And I'll talk about maybe taking some shortcuts along here so you don't have all that stuff on your paper. But let's do this. Let's go down to letter D. Okay? Let's talk about that one. So I'm going to graph. In this one, I'm going to start to talk about some of the things that you can do together. So I'm going to start off with the parent function again, just because we're brand new to this. So 0, 0, up 1 over 1, up 1 over 3. Okay, so that would normally be my parent function. The first thing I'm going to do here is I see this -2. The negative in front says that it's going to reflect over the x-axis. So I've got a reflection over x, and I've got a multiple stretch of 2. So if you think about it, if I were to take, again, 0, 0 doesn't reflect over the x-axis, and you can't stretch 0. 0 is always 0. It's a nice thing about it. The second point, however, if I reflected over the x-axis, it would normally land at 1, -1. But I want to stretch it by a factor of 2, so I'm going to let it land instead 2 units down instead of 1. So I can kind of kill 2 birds with 1 stone there. And now I've got the negative and the stretch done. The same thing with 4, 2. Normally it would reflect over to 4, -2, but I'm going to double that distance. I'm going to stretch it by a factor of 2 and make it come all the way down. I can't draw for some reason now. Here we go, come down to 4. And I'm not going to draw it yet because I've still got 2 other things that I want to do. I need to go 3 to the right and 1 up. Okay, so that's what this is. 3 right, 1 up. So I'm going to start at my vertex. I'm going to move 1, 2, 3 to the right, 1 up. I'm going to do my second point. 1, 2, 3 to the right, 1 up. Same thing with my third point. 1, 2, 3, 1 up. And I'm going to draw my graph. Okay. All right. Let's take a look at letter E. This one's going to be a bit of a tricky one here. Let me see. Actually, let's go back to, well, we'll do E and then we'll go back to B. All right, so E, this is a parent function parabola. The negative in front tells me to flip it over, and the 1/4 in front says to shrink it to 1/4 its original height. Think about that. Shrink it to 1/4 its original height. So here's my parent. Up 1 over 1, up 3 over 1. Same thing on the left. I'm not going to draw it. First thing I'm going to do is flip all those over. As I flip them over, I'm going to shrink them. Instead of going up 1 over 1, think of it as going up 1/4 over 1. Okay? So I would go down 1, leave 0, 0 alone. I would go down 1/4 over 1, over 1. All right. And the next one would normally be up 3. So I'd need to go up 3/4, or in this case, down 3/4. Now, my points are not going to be pretty here. Again, think of it like this. This blue point that was up here at 2, 4, it needs to be 1/4 of that distance high. 1/4 of that distance. 1/4 of 4 is 1. So that point should end up at -1 here and -1 here. And my, whoops, I've got a +5 on here too. I almost missed that. Okay, so then I need to bump all of those up 5. So my vertex, up 5, down 1/4, down 1/4, down to 1. Remember, all I'm doing is moving all of these up 5. So rolls around, just like that. At any point, feel free to turn off the video and try them on your own. Letter B. All right. This is an absolute value. So my parent function would normally be just like this. The negative tells me to flip all those. Okay. I can do that. Reflect them. Reflect, 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 reflect. Not going to draw it yet because I've still got to go 3 to the right and 4 up. All of those points, 3 to the right, 4 up. So my green point's starting on the far left. Okay, 3 to the right, 1, 2, 3, 4 up. 1, 2, 3, 4. That's the furthest. That was this point right there. Second point, 3 to the right, 1, 2, 3, 4 up. 1, 2, 3, 4. Vertex, 3 to the right, 4 up. Fourth point, 3 to the right, 4 up, and you should start to see the same graph appear, and then you can just kind of finish it off like this. All right, and there's your absolute value. I'm going to let you try C. I'll let you try, looks like I have 2 sets of B's, C's, and D's down below. I'm not sure what happened there, but I'm going to let you try the rest of these, see what you can do with them, and then we'll come back and take a look here. All right, so my parent function on C would normally be 0, 0, 1, 1, 4, 2. I need to triple the distance, the vertical distance of all those points. Triple the distance. Well, you can't triple 0, so it's still 0. Instead of going up 1 over 1, I want to go up 3 over 1. Instead of going up 1 over 3, you want to go up 3, 1, 2, 3, over 3. All we've done to this function is a vertical stretch. That's it. That one's done. Going down to letter B on the bottom. This is an absolute value. Don't worry about the -5. This time, I'm not going to do the parent because I know that that 2 on the outside there changes the slope of each ray. So I want you to think about that. Normally, I would start at 0, 0 and go up 1 over 1. Now I need to go up 2 over 1. Up 2 over 1. And I'm going to do it on both sides. That's what that number out front does. Now I need to take all of those points and drop them 5 units. So down 1, 2, 3, 4, 5. Drop the vertex. Drop the second point, 1, 2, 3, 4, 5. And you might even be able to just say, okay, well, if the vertex is at 0, -5, I just go up 2 over 1, up 2 over 1. And I can just do that same thing here because this is, again, just 2 straight rays that intersect down there at the vertex. All right. Next one, parent function. 0, 0, 1, 1, 4, 2. I need to cut that in half and flip it over the x-axis. That's what those front numbers are telling me to do. Flip it over the x-axis and cut that vertical distance in half. I can't reflect 0 and I can't cut 0 in half. I can reflect 1, 1 over to 1, -1 and then cut the distance in half. I can take 4, 2, reflect it over to 4, -2, and cut the distance in half. Now, all I have to do is drop everything down 1 whole unit. So my vertex, my starting point, down 1. My next point, down 1. My next point, down 1. There's my final graph right there. Last one. All right, I'm going to ignore what's inside the root and what's outside the root. This is a parent function root that's been doubled. All right, well, again, we don't double 0, so it stays at 0 to start. Normally, I would go up 1 over 1. I'm going to go up 2 over 1. Normally, after that, I would go up 1 over 3. I'm going to go up 2 over 3. Remember, I'm doubling the vertical distance. All right, now I'll go back and look at the +1 and the -4. The plus 1 tells me to go left 1 and down 4. So all those points, left 1, down 4. Left 1, down 4. Left 1, down 4, and I'm done. Draw the curve. Okay, so that is that one. And the last one I'm going to look at here is, and I'm just going to do a couple of these and then I'll put the key on for you guys. So we have this graph here, and it's just a triangle, and it says to graph each transformation. So I just want you to think about this. When you see x minus 2 in the parentheses, what does that tell you to do? Hopefully you said right 2. So I'm going to take that triangle and I'm going to move it to the right 2. Now, on that triangle, there's 3 key points. 1, 2, 3. I don't care about any of the other points on there. I'm going to shift those 3 points to the right 2. All right? If I shift the one on the right side to the right 2, it ends up at 1, 1. If I shift the one on the left, it ends up at negative 3, 1. If I shift the one in the middle, it ends up at 1, 4. There's my new triangle, shifted to the right 2. Piece of cake, huh? All right, I'm going to leave letter B for you guys. I'm going to take and look at, I'm going to have to shrink a little so I can keep everything on here. Take a look at letter C. Letter C says reflect over x-axis, and the 2 says to go up 2. So you reflect first. Remember, left to right. We reflect first. So I'm going to take that triangle and I'm going to reflect it. Each of those points gets reflected over the x-axis. So negative 5, 1 becomes negative 5, negative 1. Negative 1, 1 becomes negative 1, negative 1. Negative 3, 4 becomes negative 3, negative 4. There's my new triangle. Now I need to bump all 3 of those points up 2 units. So I take each one of them, 1, 2. 1, 2. 1, 2. Boom, boom, boom. There's my triangle. All right, letter D says take your parent function, which is the one in the upper left, reflect over x and y axis, then down 3. Down 3. I'm going to do these in the order in which it tells me. The negative out front says reflect over the x-axis first. So I'm going to take that triangle at the top. Again, I'm just going to reflect them just like we did a minute ago. Negative 5, negative 1, negative 1, negative 1, and negative 3, negative 4. There's my reflection over the x-axis. Now I want to take those and reflect them over the y-axis for this negative on the inside. So I'll do that next, over the y. So the point at negative 1, negative 1 flips over the y and is now here. The point to the far left flips over the y, is now here. The tip of my triangle down at the bottom reflects over and is now here. And then I drop them all down 3. So 1, 2, 3, done. 1, 2, 3, close enough, right? And 1, 2, 3, and there's my triangle. Easy cheesy lemon squeezy, huh? I think you guys will do fine. This is left 1, down 3. That's it. All right. We'll see you guys on the next one.